Welcome one and all to the video on the half-angle formulas, where you will learn to use the half-angle identities to make algebraic substitutions in order to simplify and verify trig functions. Here are some review slides on the Pythagorean theorem, where you have a squared plus b squared equals c squared, where you may need to find one of the sides to a right triangle given two of them. Here's the review on the trig functions themselves on sine, cosine, tangent. Again, we will primarily focus on the key wording of opposite, adjacency, and hypotenuse. Here's the main meat of the video itself, which is the half-angle formulas for sine and cosine. These two trig functions will be our primary focus, and what it is about is, given an angle that you may or may not know, if you were to cut that angle in half for a sine and cosine function, you can find the actual value using these square root formulas. The plus and minus in the front is just to say if your value is positive or negative. You have to put a positive or negative sign in front of it. That will be told to you in the beginning of the problem, so to make sure you pay attention to the directions. And now let's just dive right into a couple examples. So here we have given to us the cosine theta is equal to 2/3. We are asked to find the positive values of sine half. So, first step is to identify the formula we need for this problem. So therefore, we are going to use sine half theta equals positive, so plus, which you don't need to put, square root of 1 minus cosine theta over 2. The first step is to take the cosine function that we were given and plug that in or substitute that into the formula. So now it's 1 minus 2/3. The next step would be to combine the values on the top. Well, 1 is not a fraction, but you can convert that into a fraction. So the 1, we can convert that into 3 over 3, which allows us to subtract it by 2/3. That's why 1 is convenient as a value, because it is very easy to convert that to a fraction when necessary. So now you subtract these two fractions together. So 3 minus 2 on the top leaves you with 1/3. Now it's still being divided by the 2, which we can convert to a fraction, 2 over 1. So now that we have a fraction within two fractions within a fraction, so in other words, a complex fraction, you apply the keep, change, flip rule. We're going to scroll back up here. We're going to keep the 1/3, change the operation to multiplication, and flip the fraction to 1/2. From this point on, it's pretty straightforward. Multiply the values on the numerator together and the denominators with each other together. So you are left with the square root of 1 over 6. Then you simplify the square root on both the numerator and the denominator separately. Technically, there was a square root of 1 there, but the square root of 1 is just 1. So therefore, that's why they just didn't even bother writing that out. The last step is we need to rationalize. We don't like the square root of 6 in the denominator. So you multiply both top and bottom by the square root of 6. That allows you to cancel the square root in the denominator. Really what's going on is 6 times 6 is the square root of 36, but the square root of 36 just leaves you with 6 in the bottom. And then the numerator is just square root of 6. And that's your final answer to this problem. So all in all, when it comes to actually using the half-angle formulas, substitution is the only new thing, or the formula itself and substituting into it is the only new thing. Everything else after that is just a combination of algebraic concepts and steps. Here's one last problem we'll do for the half-angle formulas. This time, if we're given cosine theta, and we're asked to find the positive value of cosine half theta. So that's the difference. We're asked to find the cosine half of theta. So just like before, you are going to find the formula that applies to this problem, which is this value this formula right here. Again, our goal is to replace the cosine theta with what we were given, so we were told that it is 1/10. Scrolling down, I need to convert the 1 into a fraction in order to add that with the 1/10, so 1 converts itself to 10 over 10. Since the denominators are the same, we can add the numerators together, so that gives us 11 over 10. all being divided by the 2 again, but we convert the 2 into the fraction 2 over 1. Apply the keep, change, flip rule. 11 over 10 is the keep. Change the operation to multiplication and flip the fraction to 1/2. Multiply the two fractions together, so 11 times 1 gives you 11, 10 times 2 gives you 20. The next step is to simplify each part of the fraction by the square root. So we scroll back up here, and now we separate it into the square root of 11 over the square root of 20. Can I simplify each one separately? Well, the numerator, no, so you're going to keep that as square root of 11. However, the square root of 20 can be split apart into the square root of 4 and 5, because 4 is the largest perfect square, which in of itself reduces to 2 times the square root of 5 for the denominator of our fraction. Once we've reduced everything as much as possible, our last step is to rationalize. So we rationalize by multiplying both top and bottom by the square root of 5. The numerators, you just multiply the two square root values together. So in other words, you just multiply 11 with 5 to get square root of 55. As for the denominator, well, the square root of 5 times the square root of 5 reduces itself to just be 2 times 5. And then you multiply those two numbers together to get square root of 55 over 10. And that's the final answer to this problem. So just like before, all in all, there's really not much new content here that you have to really apply. The only thing you need to know is the formulas and know which one to use. But when you get to the part of substituting what you're given into the formula, all it is just algebraic steps. A lot of fraction manipulation operations, keep, change, flip operations, rationalizing, and simplifying. So keep that in mind when you tackle these problems on your own.